So here's my video for the course project in which I will be covering task 2. So this graph here shows the natural logarithm of the original points being plotted, and it's clear that they all sit on a line. Part B has us create an equation that estimates the line. We can find the matrix A by taking the points from table 2 and putting them into the y equals c0 plus c1 x form. Then we can put those equations into the form ax equals b. Next, since we need to find the transpose of A times AX equals the transpose of A times B, we can start by figuring out the transpose of A times A. And then we can move on to the transpose of A times B. Both of these are done using matrix multiplication as shown here. We end up finding this line after creating the augmented matrix and putting it into RREF form. Graphing it on Desmos, it's clear that the estimated line fits the points. In part C, we can take the ln of both variables in the equation, as shown here, and we get back a curve, this one, that fits the points in table 1, as shown in the orange. Looking at Kepler's third law of motion, it states that the cube of the mean distance should equal the square of the orbital years. After calculating them, it is clear that the third law holds. In part D, we take a look at Kepler's life. Kepler was a German astronomer who discovered the 3 laws of planetary motion. Among other things, he also discovered more semi-regular polyhedrons and how light behaves in a telescope. With part D done, that concludes task 2 of the project.